So this video will teach you how to find dy dx given an implicit function. This is an example of an implicit function. If I want to find dy dx by doing implicit derivative, I have to think of this as a product of two functions, right? And this is just one function plus another function. That's easy to find the derivative with respect to x. So here we go. If we do a d dx on both sides, then the d dx of this is equals to the d dx of that. The right is really easy because the sum rule allows us to find the x derivative by adding the individual x derivative. But for this one, we require product rule. So you must say, I differentiate my x squared, which is 2x, and try to do the d dx of y squared. And second time around, I keep my I made a mistake here. I differentiate my x squared and I keep my y squared. The second time around, I will keep my x squared but differentiate my y squared. So the question is, what do you get when you differentiate your y squared? When you differentiate the y squared, you don't just get 2y. You get 2y times dy dx. Because this is a x derivative, not a y derivative. Alright? So the derivative of this is 18x. Now this one is sort of similar to that. The derivative of 4y squared is not just 8y, but you must multiply by dy dx. So I have this term here. Now all I need to do is solve for dy dx. How do you solve for dy dx? You move all those that has dy dx on the left side and all those terms that has no dy dx on the right side. So you can see this term is moved over to the right side, this term is moved over to the left side by adding and subtracting. So now the left side has the dy dx. I can factor that out. Oops. And if I do, I get 2x squared y minus 8y here, but 18x minus 2xy squared there. So solving for dy dx will give me dy dx equal to this thing here over this thing there. There we go, we found dy dx. And if we want the slope of the tangent line at a point, all we have to do is substitute the x coordinate and the y coordinate.